In special right triangles, the sides of the triangles were easy to find based on rules because we have special rules for 30, 60, 90 degrees and 45, 45, 90 degrees. But what if you have right triangles that aren't any of those degrees? What if you have 47.5 degrees for your angles? In that case, there aren't any special right triangles for them, and we have to use things called trigonometric functions. So these three trigonometric functions are the ones we're going to be focusing on this year. There are actually more, but these are the three main ones that are most commonly used. Okay. Now these are just three names, so we call them sine, cosine, and tangent. And all it is just a name for the ratio of two of the sides in a right triangle. Okay, so we're going to go through each of them throughout the week. We're going to focus on just tangent today, and hopefully it'll be easier to understand the other two afterwards. Okay, so let's first start off by labeling each of the sides and how we can identify them. So when we are talking about trigonometric functions, we're always going to refer to a single angle per problem, okay, or per question. So in this, there's a little symbol here for angles, and we call this theta. So if you ever hear me saying theta, that's what that is. It is the angle that we are referencing to. So we will call this the reference angle. Okay, theta. Now, referencing that angle from here, we need to locate the side that is opposite to that and the side that is adjacent to that angle. Okay, so the side that is opposite to that angle would be across here, which would be the one that's not touching the angle. Okay, so this is opposite. So this is the opposite side when we are referring to that angle. Okay. The adjacent side would be the side that is next to it. Now there are two sides that are next to it, but if you can see, one of the sides is the hypotenuse. Okay. So the other side will have to be the adjacent. Okay. So the hypotenuse will never be called the adjacent side. It will always be called the hypotenuse. So we're going to be using these three letters in this and future trigonometric ratios. Okay, so the first one we are again talking about is tangent function. And again, all of these are just names for the ratio of two of the sides. For tangent, the ratio is going to be the opposite side divided by the adjacent side. Okay. So in shorthand, because I don't want to keep writing tangent function, opposite side over adjacent side, we're going to do a shortened version by using the word tan. So tan would stand for tangent. Okay. Tangent. Now for every trig ratio, all of these sine, cosine, or tangent, we always have to refer to an angle. The angle is very important because it tells us which ones are going to be opposite, which one's adjacent, and to get the right ratio. So with tangent, we will always have the angle right next to it. So tangent theta, or the angle, equals opposite over adjacent. So I just write O over A for opposite and adjacent. Okay. So again, this is an angle that will always stay with tangent. And we have, it's like tangent times that. So this here is your ratio of sides. So let's do just one problem here just to set up the ratio. Okay. So it is very important that the angle that you are working with, the reference angle, always goes after sine, cosine, or tangent when writing a problem. So let's say I want to find tangent. Okay. I don't know what angle, so I'm going to tell you I want to find tangent of C. Okay. So that means my reference angle here is C. So I'm going to just mark C as the angle I want. It's a little circle with a dash in the middle of it. And now I'm going to identify, based on that angle, which ones will be my opposite and which ones will be my adjacent. Okay. Opposite side would be 12. Adjacent will be 5. And of course 13 is hypotenuse. So now tangent of C, we are using opposite and adjacent. Okay. So tangent of C equals 12 over 5. Okay. So that's what it is. The ratio for tangent when looking at angle C is 12 over 5. So this is my answer. Okay. Now, if you noticed, I'm using only the acute angles. I'm not referring to the 90-degree angle. If you use a 90-degree angle, you'll get either 0 or undefined, or 1, but usually when we are doing these types of problems, we are never going to use the right angle. We are only going to use the acute angles. So I'm going to write a side note here. Only use only use the acute angles. Do not use the right angles.